because that's how we have planned for the timing from 3 to 4. Okay. I'm sharing a website on the chat screen. uh, we have noticed that this particular person has recorded videos of CG100 for almost all the units. So in case you have want to quickly review, each video is for hardly a few minutes. That might be helpful. Casio UK also has their own website. Ms. Revati will share that link as well with you. But the person who has shared these videos are for A levels, but all the questions, I mean, for the calculator use, it doesn't matter. Correct? Okay, let's start. My name is Shirisha, and I've been teaching Math HL since 2012 now. And both the old syllabus and also AA and AI both are familiar with me. I'm also the examiner for Math AA HL Paper 1 and Exploration. So whatever I'm sharing with you, I have an understanding of what kind of questions come for your examination. Okay. Like I mentioned, today we will focus on using the calculator with statistics and probability questions. Ms. Revati, if it's possible for you to share that document once again on the chat screen, because I can't upload a file in case they haven't yet looked at it. We have a document where we have looked at some questions. I'm going to share my screen now and start showing you that. We'll be at those questions only. Okay. So we'll start with descriptive statistics. And the first question says to summarize. And when we say summarize, the most important parameters for us are mean, standard deviation, median, and so on, right? So we are going to look at how the calculator does this. And I have already entered the data so that it saves us time. So in list 1, I have entered the first question information, 4757716. So this was my data for the first problem. Okay, and I wanted to find out the summary of the statistics. So I'm going to use the tab key. And here the first option, calculate summary statistics, is what I'm going to say OK for. It is a one variable statistics. Yes, my data is in list 1 and frequency is 1 because wherever the data was repeating, I was listing it. So therefore, frequency by default is set to 1. If there is a frequency column, we will look at it in the next question, then we will have to use that. And we scroll down and say execute, and we get all the details needed for one variable. So X bar is your mean, your sigma X is your population standard deviation, Sx is your sample standard deviation, number of data points that you have. And even if you wanted to draw the box plot, which we are going to see in some time, all the 5 numbers summary, which is minimum, first quartile, median, third quartile, maximum is also given, mode is also given to you. So all that you need, entire thing is given here in your summary statistics, right? That's your first question. Your second question, like I mentioned, has a frequency column also. So in addition to, so if we look at our second question, it again has a summary, but this time in addition to the data, I also have a frequency list. And my data now is in list 2 and frequency is in list 3. So I would go back to my one variable statistics. Look at this. You use your arrow key to say that I have my data in list 2 and scroll down. Identify that your frequency is in a list. It's not 1 now, and it is in list 3. Now go to execute, and this time you have information for a grouped data, which means a frequency table. Again, the same information is being given. Your standard deviation, mean, median, mode, everything is the same. Just that this time it is for group data, which means has a frequency column also. Okay, let's go back and look at the next question. The next question is asking us to draw a scatter diagram for to find out correlation if there is between math and physics scores. The question is only talking about scatter diagram, but we will also look at other information about correlation and line of best fit. So my data is now in list 4 and list 5. These are my scores of math and physics. So if we want to compare, see, these were your scores which I entered in my list 4 and list 5. So I will go back now, and this time, what do I want to do? I want to look at, I'm sorry. I want to go to statistics graph because I want to draw a scatter graph. And on the graph 1, I want to do a scatter. And where is my data? My data is in list 4 and list 5. So say OK. X list is in list 4. So we are going to look at this. Enter your list 4. Your Y list is in list 5. Frequency is not associated with it. And you're going to execute. And you can zoom out to see that clearly. One question that usually comes here is they ask you to look at the trend and comment on whether there is a positive, negative, strong, weak kind of a correlation. So that's one part of the question. The second could be about drawing the or doing the two variable analysis, right? Or linear regression. So I can have a two variable analysis, which means I can find the mean and standard deviation of X as well as Y. Or I can do a linear regression. And again, linear regressions, you can do it of the form AX plus B or A plus BX. In IB, we recommend the students to go with AX plus B because that's how the marking scheme is telling us the answer. And now when you do linear regression, what it is telling you is what is the line which is closest going to match the behavior of the scatter graph. So we are assuming that there is a linear trend here. So the values of A and B give you the line of best fit. So you're going to write Y is equal to AX plus B. So in case you have a different value of X that for which you have to find Y, then that's what Y is equal to AX plus B is used for. In addition to that, you also have the correlation coefficient, the Pearson correlation, or it's called the product moment correlation value R, which is 0.877. Now that indicates that it is a strong positive correlation. Even when we looked at the diagram visually also we could say that. R square is different from R, and normally if R square is also found in case of non-linear regressions where we say what is the percentage of points that are matching with the curve of regressions. However, R is only for linear regression when we are looking at linear trends. So that's something we have to remember. Mean square error, usually mean square error question comes more for AI students. And what mean square error is really telling me is the difference between the actual point and the point on the line of best fit. How much is the error? Mean squared error, because I don't worry about whether the point is above or below. I'm finding how far is it. That's what is the mean square error giving you. So all the information that you need from the linear regression comes here. You could also draw the line of best fit. So once you execute, I even get the line of best fit graph. Sometimes the paper asks you to sketch that. So do the scatter graph and draw the line of best fit also. So that's as well shown to you. And what is the equation? Well, you have the values of A and B. So AX plus B is the equation of this line. So you know everything that you need to know about this linear regression. Now, the only difference between Pearson correlation and Spearman will be, if you notice, let me go back to the data. List 4 and 5 was giving you physics marks and math marks, right? If I had to do the same exercise with a Spearman correlation, which means there is no linear trend, but there is a monotonic trend between the two variables, then I'm going to rank them first. And I'll do the same process of finding linear regression, but with the ranks of the variables rather than the variable value itself. So the process is same, but I will need to prepare two more lists where ranks of math marks and physics marks will be entered. And I need to find a linear regression line for the ranks. That's how I do Spearman rank. So the procedure on the calculator is the same actually, but with one with the data and one with ranks. Okay, let's look at the next question now. So that's scatter graph. And so we are looking at box whisker diagram. And I'm just trying to do two box whisker together because box whisker, one of the uses is to compare information. For example, if I want to compare between results of 2 years. So here there is some information about men and women. Maybe it's timing of a race. Maybe it's, then I don't know what is the data. But, oh, test have already told us. So box whisker, and we are trying to compare them. When I compare, what do I look for? Comparing the median, comparing the interquartile range, comparing the maximum, minimum range, and so on. So that's what I'm going to look at. So first of all, like all other things, I have to enter this information. So let's see, where have I entered this? So my list 6 and 7 has information of data of men and women. And I want to find out, I want to draw a scatter graph. So I'm going to use graph 2 for doing a box plot. And it was in list 6. This was list 6. And frequency correct and everything else is fine. Do I want the outliers to be seen? Yes, I want the outliers to be seen, so I'm going to keep it on. I hope everyone knows that there is a formula that is given to us for outliers. It's either 1.5 times interquartile range more than the Q3 or 1.5 times interquartile range lesser than Q1. So that's what they are saying, that do you want to see them in your diagram? Okay, I'm also going to set up graph 3 also for a box plot with data from list 7. And here also I want to have the box, the outliers kept on. And now I go down and I say execute. And before that, let me make this none so that that doesn't get graphed. And now, so I have both my box plots. You may say, well, it's, how do I read that? If you look at these 3 dots, it gives you the option of tracing. So it's starting with the outlier of the minimum of the first graph. It's going to all the other values. So outlier, minimum, first quartile, median, and then if I go further, I can also trace on all the diagram. So the values are here. Below, you can see the values clearly. So that is how you are going to do a box plot and comparison of it. Can go back, and what if we needed to look at a histogram, because that's another thing that often comes. And here, this is the data that I'm trying to graph for an histogram. Now, for a histogram, we know that these are bar graphs. So I need to understand what is the minimum value that I need to start with and what kind of bins or range of values that I need for each of the bar to be graphed. So if I'm looking at the data, I think I can set 140 as the minimum and maybe 190 as the maximum, because I'm not seeing any value less than 140 and more than 190. And maybe I can do bins of 10, but that's up to you how you want to look at it. For example, we are doing that. So again, I have entered the data in the list. I'm going back here. I want to maybe change all this to none, because I don't want these graphs to be done. I only want a histogram now to be shown. And go back to any of the graphs that you want to. And this time I'm choosing a histogram. And my list is in list 8. My data is in list 8. And yes, that's it. Let's check if there's anything that I need to enter. No, this is only the color. This is also only the border color. Nothing here to include. And okay, the start value, I'm going to set it as 140. And the width, I'm going to set it as 10. And execute. Again, I can trace the values to ensure that I'm getting it right. And that's how the histogram will be. So cumulative frequency graph is what we are not able to graph on the calculator, but box plot and histogram. But you know that from histogram, it's not difficult for us to graph the cumulative frequency graph. For AI students, it might be important. For AI, it is less frequent that we see graphs of cumulative frequency or box plot to be drawn, but it's still a part of their syllabus, so not that cannot come. Okay, so let's go back to our data now and see what else we can do. So these are not difficult. See, once you are on the spreadsheet, it's very easy for you to figure out. You're pretty much going to the same tool if you see and using most of these tabs. Pie chart is the last one. Again, we have not that we have really seen pie chart for an IB question, but nevertheless, let's see how do we do it. Again, we are entering the information. We are going to a graph. We are looking at what are the options I have. And pie chart is what we want. We want to take it from list 9. And do you want display as a percentage or as data? Whatever, you can choose anything. Okay, I'm going to choose data, but you can also choose as percentage and then say execute. So you are getting a pie chart. So ABCD, it's by default, it's always called, the data is called ABCD only. Okay, so it was a coincidence that in my table also it was called ABCD. So here in the calculator, we don't have a option of setting the variable values to something that we want. For example, it was a name, then I don't have, so I will always have ABCD as the by default option on the calculator. Now let's look at the next question. So this is all that we do in descriptive statistics. Majority of the times that we see is question on summary of statistics, which we saw in the first one, either with a frequency table or without. We see a scatter graph very popularly coming in, which, again, questions on what is the correlation, both Pearson as well as Spearman rank correlation. That these are more common questions that we have seen. So we'll move to probability and mainly probability distribution. See, if you know probability distribution questions, majority of the working you do on the calculator. So here I'm looking at questions where variables are defined. However, for you, the working mark really comes from you defining the variable. It's usually given as a word problem. So you identify the variable, saying that X is equal to the number of people coming late to school, or X is the number of blue colored marbles, or whatever X is, and then X is approximated by binomial distribution. So the first line that you see in your problem, you identify that. Okay, in this, because we are looking at calculator questions, I have already taken a variable which is binomially distributed. And what are the two numbers that are being shown here? 10 is the number of trials and 0.4 is the probability of one success. And we have three things that we want to answer. What is the probability of exactly two successes? What is the probability of less than or equal to 5 successes and greater than or equal to 3 successes, correct? So what are we going to look at? So I'll go back now. I was in the statistics menu till now. And this time I'm going to go to the distribution menu and I'm looking at binomial probability. But before I move on, just wanted to check. Revati, is the screen clear? Is everything audible clearly?
Yes, sir. Yes, ma'am. It's audible and it's all clear, ma'am.
Okay. Any questions, if any of you have, can you put it on the chat screen? We'll restrict today questions on statistics and probability only. But other questions, we will definitely take it and resolve it and share it with you. But for now, I'll take a minute's break and see. Do you have any questions? Then on probability or statistics, then please share it on chat screen. Okay, I'll move ahead then. So we are looking at binomial distribution. And the first question I have, so good part on the calculator is that it gives me option to select all types of tails like less than, greater than, equal to, and in between. You know, in some calculators, only the left tail is working. So that's one ease or time saving factor here. I'm going to first choose the equal to category. What do I have? Do I have data in the list? No, I have variable only. But if I can also have list, usually questions in IB, we have not seen binomial probability with lists coming in, but that's an option that you have on the calculator. So I want 3 successes. How many number of trials do I have? 10. That's what the binomial distribution said. And the probability of one success is 0.4. So this is what you enter for each of the problem. So if you see, good thing is that it gives you all the probabilities for 1, 2, 3, 4, 5, 6 for till 10. But the one that you are asking for is being listed in blue. Now here, I would want to show you an option. If I want to do inverse binomial, right? So for example, I know that there is 30% probability of something happening. And I want to find out. Okay, right now it's 0.5. It's not allowing me to enter. Fine, let me check on this. But I can also I'll show you in a minute how I do the inverse binomial thing, where I can set the probability of success and find out what is the variable going to be. So here, if I look at the less than, okay, and so now the probability of less than or equal to 5 is 80%. If I want to change this row, yeah, so it doesn't allow me to change the probability when it is equal to category because obviously there is no option here. However, for greater than or less than, when it's cumulative probability distribution, then it allows me to change the probability and it will give us the corresponding number of trans that I need. Say, for example, if I can change this, then it gives me the options for other things also. So I don't need to go back and change everything. I can change here also and check for the details. Similarly, the greater than tail or the in between tail. So whichever question you have, all the options are available here. So if we take the in between, then it allows you to give the lower and upper. So depending on what your problem is stating, you will be able to define this and give your distribution. Okay. Same thing with normal distribution. So if we look at the question, again, we have again, in your exam, the variable may not be defined. You may define it as time or length or distance. You will say that it is approximated by a normal distribution. What are the two numbers there? 20 is the mean and 5 is the standard deviation. 5 square, they write it because sometimes it is also written as mean and variance. However, 5 is what you will enter in your calculator when you're doing it. So the question is asking us less than 10, greater than 25, and in between values also. So very similar to the binomial, you can choose the tail. I have a variable. You can choose to keep the z-scores on, which is for your standard normal distribution. Correct? So I'm say, for example, I'm choosing less than 10. My mean was 20 and my standard deviation 5. So it's already giving me that option, right? So here, if I choose 50%, if you see, it automatically set the z-score to 0. That means mean is where the probability will be 50%, right? Say, for example, if I set it to 30%, it is giving me the z-scores. If you don't want the z-scores and you want the x-scores, then you can keep this off. And now display whatever you want. Say, for example, this is 15 and so now it is going to give you x. Now, if I want to change this to 0.80%, then it is going to change the x value accordingly. This is how we do inverse norm when we wish to find out for a given probability what is the boundary above or below which. Again, like binomial, you can set the tail in whichever direction you want, greater, less than, or in between. Now, there's also a problem where if we don't know the mean and standard deviation, then what do we do? So for both these categories, we will have the z-scores that we can keep on. Now you saw the mechanism on how we did that, right? So for a 30% probability, what is the z-score, and for a 20%? And then you will write two equations and two unknowns for z in terms of mu and sigma and solve them using equations. So that's also an option available because you can keep the z-score on. It is much easier for us to do it with this. So that's as far as probability is concerned. And we'll now move to hypothesis testing. And I know hypothesis testing is only for AI students. But the AA students, if they are looking at any exploration where they are including hypothesis testing, then this might be useful. So the first test is saying that a dietitian is claiming that protein intake is 20 grams and then a sample is taken. And the sample mean and standard deviation is given at 5%. So we can we are checking whether the mean is changing or not. And the test that we use for comparing the mean is t-test. And here it's a one sample because we have only taken one sample of 9 adults. So we'll go to our statistics and we look at hypothesis test. We are doing a t-test. We are doing a one sample t-test. And we have data as a variable, not in a list. What do we know? The information tells us that 18.5 grams. So we are checking is the mean less than what is to be. So this is what we are checking for, right? So what was mu0? 20 grams was what was given. But from the sample, what did we find? 20 grams is what originally they're thinking it should be, but the sample says 18.5 is the mean and 2.6 is the standard deviation. So 18.5 and 2.6. And the number of samples are 9 because 9 adults, right? Degree of freedom, remember, is n minus 1. Here they are not asking for degree of freedom, they're directly asking us n, and we are saying this. So there are two things told to us. 5% significance. So we can compare p-value, right? P-value is 0.06, which is greater than, so we can draw the inference. The other way is to compare the t-statistic. So the t-statistic here is minus 1.73. But what do I compare it with? I have to compare it with the critical value. And a good part of the calculator is it gives us the critical value. So let's go back to the distribution. And it has a t distribution also. So this is a new thing that Casio has added here. What were we looking at? We were looking at mu less than mu 0, right? So we are going to look at the tail here. And degrees of freedom will be 8, 9 minus 1. I'm just going to keep x as it is. I'll tell you why. And execute. Now here, I'm going to set my probability to 0.05. Less than that. And what is the t-statistics? Minus 1.859. So my absolute value of the t-statistic is less than the absolute value of the critical value, 1.859. Either the t-statistic is greater than the critical value, then I draw an inference, or p-value is less. Either one I can compare. So both are available to you on the calculator. The critical value is also, so even if the exam, it is not given, you can find it out on the calculator. And we can do that for chi-square also. We will see that in a minute. Okay. So the problem didn't ask you to find this. Okay. I'm just giving you this additional information for you to say that you can find the critical value if you want. Especially if you are using it in the exploration, then this might be a very useful thing to display as an additional information to show that you are aware that both the statistical measure and p-value both can be compared. That's the reason I'm sharing this with you. So let's look at the next question. The next question says shopkeeper is selling jam and it is normally distributed with mean of 150 grams. Now, I hope you all know that for t-test or for most of the hypothesis testing, we assume normal distribution. So 150 grams is the mean. And then there is a customer who's complaining that a mean weight of 8 jars she had brought was only 147. The estimated weight of these 8 jars from the 8 observations, the standard deviation has come to be 2 grams. Test whether 147 is significantly less. Well, this is exactly same as the previous problem. If you know, instead of the 20, now we have 150 as the actual mean. We have 8 jars of jam, which means the number of samples is 8 and standard deviation is 2. Significance level is also given. So exactly same question here. One thing is, in both cases, if you have seen, it's a one-tailed T test because we are looking at the less than category. But if, for example, sometimes they ask us that mean is not equal, okay? So let us do the same question, but as a two-tailed test so that I'm able to see the difference. So I'm going to look at statistics. I'm again doing the t-test, but this time I'm going to check this. So when I do this, so this was 147. The sample gave me 1 and 2 grams was the standard deviation. And this was 8. This time when I do two-tailed test, what I do is I compare with a probability which is half of 5% because it can be 2.5% on the left and 2.5% on the right. That's the only thing that really changes. So this part of the graph doesn't change. Now p-value I have to compare with 0.025. That's what I need to understand when I'm doing the two-tailed test. And two-tailed comes when mu is not equal. Not equal means it could be on either side, right? It could be greater or it could be less. That's why this becomes the two-tailed test. In both cases, it is one sample only. Okay. We can also find the confidence interval. This is again new. Earlier calculated fx-cg100 did not have. And here I'll need a little help from one of you to enter, because I've not entered these values. I just wanted to show you how I enter the values also, and therefore I didn't enter these. So if one of you could, Revati, if you could just dictate these six numbers for me, if you have the document with you. Is it possible, or let me do it myself? 26.8 and 20. Okay, let me add the numbers and just show you how the confidence interval is done. So it's okay if I'm making a little mistake in the entries, okay? Because the idea is to show you how the confidence interval is done rather than the actual answer. So I'm just entering the values without worrying about whether it is correct from the problem or not. And say I have this data and now I want to find out the confidence interval. So I am not doing hypothesis test, I'm doing confidence interval. And confidence interval for a t-test. And it's a one sample interval. My data is in list. You all remember which list was it? This was list. Okay, let me go back and check once. It was list 12. Okay. And I have 90% confidence interval. And this is list 12. And I'm going to execute. So I get the lower and the upper confidence interval. This was earlier not available. We had to make that calculation saying mean plus or minus using the standard deviation. But now this is automatically given in your calculator. This is especially useful for AI students. And that's why I wanted to show this to you. Okay. And now we have come to chi-squares. And again, in chi-square, we know we have two kinds of chi-square tests. One is the goodness of fit. And what goodness of fit means is that you think that your sample is following a particular kind of distribution. It could be binomial distribution. It could be a uniform distribution. So your expected values will come from the distribution that you are assuming it to be. And you compare that distribution values or expected values with the observed ones. So you're seeing how different they are. The question that we are taking here, we are saying a 5-sided die is rolled 100 times and carry out a goodness of fit to test if the die is fair. If the die is fair, then we know that it should have a uniform distribution, right? That means all of them should have equal chance of appearing. So if it is rolled 100 times, then each of the number must appear. If it's a 5-sided die, each must appear 20 times. So your observed list is when you did the actual experiment, you found the numbers to be 14, 22, 20, 18, and 26. But I know that in a fair die, it should be, all of them should be 20. So what I have done is I have entered the observed one in list 10. Okay. And the expected one in list 11. Okay, and that's I'm going to now do the chi-square goodness of fit test to see if they are remarkably different from each other. Then the test will tell me that. So again, I'm looking at hypothesis test, and which hypothesis test am I doing? I'm doing the chi-square, and I'm doing a goodness of fit, and here I have observed in list 10 and expected in list 11. Degrees of freedom. So how many data points do I have? From there, subtract 1. So how many do I have? 5. So 4 is my degree of freedom. And I'm going to give this space in list 13 because in list 12 also something has been entered. So what this extra column is needed is it will calculate the observed minus expected the whole square divided by expected. So the chi value for each of them, how much is it far from the expected is what it will calculate and enter in your list. That's why you need. So we have got two things now. Again, we've got a statistical measure of 4 and we have got a probability value of 0.406. At 5%, we know P is greater than, so we will accept the null hypothesis, correct? Which means we will say that yes, the die is fair. However, here, like again I said, we can also compare the critical value. So if we go to the distribution, I can look at the chi-square distribution here. And what am I checking for? I'm looking at the tail say less than. I will put my degrees of freedom as 3 and execute. And I want I'll in fact change the tail to greater than because that's the critical value. So higher than that value is what I want to see. So I'm going to change the tail to greater than. And now the probability. What is your probability? Your significance level is your probability. So you got the critical value as 7.8147. What is the statistical measure that you got? 4. So 4 is less than the critical value or P is greater than the significance level. Both mean the same. But you could be again comparing either one of them. Even if your exam paper doesn't give you the critical value, you can check for that using the calculator. So that is the use of doing this. Now we are looking at the last test, which is the two-way test. Again, we have here, I'm not worried about what question is being followed, but the main thing wanted to point out is here one of the entries. So here they are taking a random sample of 200 voters and we are looking at whether the attitude and the political party they supported, is there any connection between them or not, right? Is there any association between party supported and attitude to the proposed form of taxation? The entry, one of the entry is 4, which is less than 5. Usually in a chi-square, we need all entries to be greater than 5. And if it is not, then we usually try to combine columns or rows to make sure that none of the entries are. Here, that's not what we are worried about. So I'm just going to enter again. I'm showing you more the procedure. So I'll show you how to enter the values and I'll not maybe worry about the exact number here. Okay, this you can try here. So I have 3 rows and 3 columns, and that's what I'm mainly paying attention on how to do it. So the first thing I need to do is I need to enter this in the matrix because it's a 3 by 3 matrix. So I am going to first declare a matrix A, which will have the observed values and enter this table as it is. Okay, whatever values I have. Again, like I said, if I'm entering some wrong values, do not worry. I am mainly trying to show you what is to be done rather than what the values are. Okay. And this is my observe. And I'm also going to set up one more matrix with the same dimension, which will have my entries for expected calculation. So my matrix B is that matrix. Now that I have set this up, I will go back to statistics. Look at hypothesis test. And this time I want to do a chi-square two-way test. So my observed is in matrix A, expected is in matrix B, correct? And then I execute. Again, I get a chi-square value which I can compare. I get a probability value which I can compare. So probability value will be compared to your 0.05 significance level and chi-square value. Sometimes the questions also asks you to state the degree of freedom, which is also given to you, but otherwise also you know how to do it. Row minus 1 times column minus 1 is what your degree of freedom is. So that is given to you here. And that is, this finishes usually all our questions for examination. These are our main questions that come. So I'm going to now open it up for questions. And in the meantime, I'm also going to share with you one exam question that we have uh, done using statistics, because sometimes there is a model, there's a data given and there is a model given, and you have to compare the two in terms of what is the mean square error between that. This question appeared in AI HL paper, and that is a question for which we have recorded, and I've shared the YouTube link with you on the chat screen. You can look at that and maybe practice that with you. We have some more exam questions that I'm going to share the recording with Ms. Revati, and she will forward that to you so that you can also step by step practice. Like I said, one YouTube link that we found very useful, I'm again going to share it on chat screen. This person, though is an A-levels teacher, but has shared the CG100 videos for almost all the units. So if anyone wants to refer to it, then that's a good website, YouTube channel to follow. So please refer to it. If you have any questions right now, I'm happy to take them. Okay, even if later you have any questions, please mail them to Ms. Revati, and she'll be able to forward it, and we will share videos of solving those questions and sending it back to you. But CG100, remember, it's quite easy. The only two things that you have to be familiar with is the options and the tools. Those are the two buttons. Let me again share my screen and show you that once. That's important thing here. See the options, there is the catalog one for each area. If you go under this, gives you all the options that you have within that functionality. Okay. And the other one is tools. These are the only two things that you need to keep checking on every aspect that you want to work with. For each unit, there is a different set of functionalities that appear under these two things. And variable is one more thing that you can, if you enter, for example, functions, they all get listed here. You can choose those. Right now, I have not entered anything, but they all get listed here also. So if I want to use a function that I entered in the thing in some other tab, for example, in calculate tab, I can like connect to it through this variable tab. That's another thing that is very useful, which was earlier not present. This is being added in Casio 100 for you to use. Otherwise, if you see, the remaining keypad is very similar. Settings is again a place where you can set your angle. You can choose whether you want complex numbers or not, your display, fraction mode, and everything else. So all those options that you earlier did, whether you want to keep derivative on or off, those are in this settings thing. Yeah. Earlier that used to also be in our menu, right? Shift menu was the option for in fx-cg100. Right now we have a separate thing. Yes. Any questions that you have? Is there any link or document that enables us to learn the calculator better? Yes, that's what we shared, right? We shared Miss Varalakshmi, we have shared a YouTube channel here. That's the link that we want you to use if you want to use the I mean, no specific functions in other units, then that's the link you can use. Okay. Okay, then Ms. Revati, I think we are done with today's session. We'll meet you again with the next unit. And thank you for joining us today.
Thank you so
Mr.
much, ma'am.
Mr. Girinath, I think he has a question. He has his hand raised. Yes, Mr. Girinath.
Hi, Miss Shirisha. Good afternoon. Yeah. So actually, I'm expecting the session on calculus. So if it is able to conduct in future, I
Yes,
hope it
yes,
is.
yes, yes. We are that is the next unit that we are looking at, and we know for AI students also with the couple differential equations, people are wanting to understand that. We are going to do that next week.
Yeah, even I'm
Sure.
going to ask the same topic, the couple difference,
Yes,
especially
yes,
the
yes. We have
final
worked
things.
on that specifically. I know we were also working on to understand. But let me show you one thing at least. Parametric equations, I hope everyone knows how to them. So that's something that is helpful immediately, if not, the entire couple differential equations. But if we now go to our type, function type, if we can choose parametric, this is one way that we are able to graph the couple differential equation answer also. Here you can, for example, I'm just going to graph a simple one. Um, So when you do this, it gives you a graph of y with respect to x and with whatever options you have entered. So I had entered a random one like t and 1 plus t, and it has given you this. But this is one option which allows you to draw the couple differential equations. So once you get the parametric equations right for your with your uh, eigenvalues and vectors, then you can use this option to graph them. But we will specifically dedicate a session for calculus for sure and share all the information. Thank you, Mr. Kirna. So, Revati, I think today we are done with the session. We will definitely plan the one on calculus for the next.
Sure, ma'am. Thank you for joining
Thank you.
today and giving us detailed information on statistics and probability, ma'am. And thank you, participants, for joining with us today. We will have another session on calculus, as ma'am mentioned, and we will keep you informed about the webinar link for the registration, and then the joining link, we'll send it. So please share it with your students and with the if you have any of your friends or where you're going for tuitions. If you have any of your friends who are into IB, please share with them also. Thank you so much. Have a happy weekend.
Thank you. Bye.